It says determine if each quadrilateral must be a parallelogram and then to justify your answer. So in number 14, what I see are these markings. These markings mean that they're parallel, and I see that opposite sides here are parallel, and that is an indicator that it is a parallelogram. So the answer is yes, because the opposite sides are parallel. And that's actually the definition of what a parallelogram is. If you look at 15, we have a set of opposite angles that are congruent. They drew this line in here, kind of like a reflexive property, so almost that you could see if you could prove these two triangles are congruent. But the catch is that you would only have two pieces of information. You'd have an angle and a side. There's nothing else in here. You need to know that the opposite angles, both sets, including this set here and this set here, are congruent. So no, because we need to know both pairs of opposite angles are congruent. And then number 16, if you look here, this one gives the indication that you have essentially isosceles triangles because these two sides here are congruent, which means the base angles are congruent, and this one as well. What you also can look at is you could say, hey, the diagonals here potentially could be congruent, but the issue is that diagonals can be congruent in both a rectangle and an isosceles triangle or isosceles trapezoid. So if you look a little bit more closely, for this to be a parallelogram, the diagonals would have to be bisected, meaning this segment has to be exactly the same as this segment, and these are telling me that these are two different lengths. So no, because we do not know that the diagonals are bisected. So number 17 says, show that a quadrilateral with the vertices given is a parallelogram. Now, what I've done is I've gone ahead and I've drawn this parallelogram based on these coordinates. So if you plot these, whenever you see coordinates, always grab out that sheet of graph paper. So plot these coordinates. It appears to be a parallelogram, but we need to double check it. One of the features of a parallelogram is that the opposite sides are parallel, and that's probably the easiest thing to check on a coordinate plane, because if you're looking at opposite sides are parallel, that means the slopes are the same. So let's just find the slopes. So for example, let's find the slope of CD. So we're going to do M, because remember M represents slope of CD. And now let's count it. So from C to D, we're going to go up 1, 2, 3, 4, and then over 1, 2, 3, 4, 5. So that has a slope of positive 4/5. Now what matches to CD? Well, that would be your FE. So let's look at FE. So we're going to find the slope of FE. Let's count. It's up 1, 2, 3, 4, and then over 1, 2, 3, 4, 5. So this also has a slope of 4/5. So far we're doing good. Let's go ahead and jump to the next one. Let's do DE. So we're going to find the slope of DE. So starting from D, we're going to go down 1, 2, and then over 1, 2, 3, 4, 5, 6. So we're going down to 6, which simplifies to -1/3. Now let's find the slope of CF. So we're going to go down 1, 2, and then we're going to go over 1, 2, 3, 4, 5, 6. So down to over 6, which again simplifies to 1/3. So what does all this mean? Well, it means that we have CDEF is a parallelogram because the opposite sides are parallel, which we shown because we showed that the opposite sides have the same slope.